So hi everyone. For our next invited talk titled AI for Agriculture, Environmental Protection and Sustainability, I would like to introduce the next speaker. So Ernest Mwebaze was a lecturer and researcher at the College of Computing and IS, Makerere University in Kampala, Uganda. He was also the head of the Artificial Intelligence and Data Science Research Group, a group that leverages computational techniques in artificial intelligence to address local problems in developing countries. His research in applying AI to agriculture and health has won him several grants and numerous publications.
Right. So thank you. Thank you to the organizers for inviting me. It's always a privilege to talk, especially on social issues related to, the work we try to do, computational tools. And so I'll try and talk about agriculture, environment, and sustainability, and sort of give a story of how we've sort of moved this journey in the AI lab. So I recently moved to Google AI in the Accra office. So I'm talking about work which I did in the lab just before that, which a group of people did, and which they continue to do. All right, so maybe just a little bit about the lab. So the lab has sort of three broad aims. It has sort of one internal looking aim, which is research, development, and prototyping. And we'll try and do this quickly. And then two out-facing aims, which are to do with outreach, so deployment, actually putting these technologies in the hands of people who use them, so the end user. And then we have capacity building. So there's a big effort to build capacity in Africa, for example. And so we have this, the broad strategy really is to marry sort of computational tools and cutting edge tech like AI with these good social problems that are impactful. And I think the key word here is marrying. So we've seen a lot of, especially in Africa, projects which paratroop into Africa. So people sort of sit far away and decide on what the solution is going to be, and they paratroop into Africa and they deploy, and then these become white elephants. They get called white elephants. So I think that the magic really is in marrying, right? So you have to choose something, and something has to choose you. And I think this is a very important aspect when thinking about social problems. And so we try and get this sweet spot between problems that can be leveraged by these tools and that can have high impact. And more broadly, we tend to look at two areas. So one is experts. So we work in Uganda and Africa generally, and experts is a hard resource to get there. So people who can do in medicine, in agriculture, in education, in etc. So people who can take a complicated problem and provide an expert decision. And we try and automate this process because there's just lack of experts. And the other thing is sort of actionable data. Is there data that people or nations can leverage on to make these decisions? And we try and see if we can sort of look at new ways of looking at this data and collecting it. All right. And maybe just talk about the opportunities, which some of them are specific to places like Africa. So we have sort of different types of data, and I'll talk about some examples of this data. Radio data, you have CDRs, that's telecom data, you have images. These are sort of different types of data which have specific contextual advantage in a place like Uganda, for example. And then, of course, there's a lot of progress now with the technology. There's better compute power, so you can actually run some of these algorithms on the phone. And cheap hardware, again. So a big part of the things we try and do is leveraging these sorts of techniques and tools on mobile phones, because mobile phones are very ubiquitous now in Africa, or at least they are becoming. And so the last advantage is generally Africa specific. So you have this ability to do this end-to-end problem solving, which tends to be quite hard generally in the Western world. So partly it's a disadvantage because we are, in some ways, you're leveraging on the lack of infrastructure legally and to sort of do this kind of thing. But you can sort of take a problem, go to a medical facility, you know, have all these IRB and discuss with the doctors and the board, and they give you this permission, and you can actually develop a solution up to the end and bring it back and sort of deploy it and test it without having a lot of blockages in this path. And this tends to happen in most of the problems. So you get the opportunity ethically to try out solutions and see what works with a very quick turnaround. All right, so I want to recalibrate a bit. So yesterday we had a very good talk in Black in AI in the dinner, for those who are there. And one of the key things that came out from this talk was that people first. So we need to put the people first. And I guess for social, to leverage social, to solve social problems, I think people need to come first. I want to sort of give you an idea of the people. Who are the people we are trying to help? Right? So this is an example of a smallholder farmer. So I'm going to talk about agriculture. Agriculture in Africa mainly deals with smallholder farmers. So these are farmers like this lady. So she's called Kezia, you know, in Western Uganda. And her livelihood basically is based on these 3 acres of land, right? So these are the guys with her, some of the guys who went with to the field. But this is sort of her land. This is what her land looks like. So it's not, you know, it's not, so it's not very visible, but she has sort of different types of crops. She's intercropping. A bit of it is cultivated, a bit of it is not cultivated. And she will essentially go there every day and sort of work on the land, and hopefully at the end of the season get some produce that she'll use to, 1, feed her family, 2, maybe sell some of it and get money to take her kids to school or for medical services and this kind of thing. So this is sort of the ecosystem. So another example is Agre. So this is Agre, the guy in the center, and these 2 sons are sort of his daily labor. So they sort of have to go and cultivate the land a bit and then maybe go to school. But this is sort of the kind of person we are, or the people we are targeting. And why? Because even a small intervention can create such a huge impact for this gentleman, right? So this is sort of the drive. So this is Agre's land, and you can't see it very well from here, but a lot of it is disease. So he has cassava on his garden, so we work a lot with cassava, and a lot of it is disease, but for a very evidently diseased garden, Agri may not know. You know, he has certain conceptions about why the garden looks the way it looks. So his garden is not very healthy. So I want to talk about what we've done, or some of the work we've done in agriculture, and basically thread through a story about some of the thoughts on AI for social good. All right, so how do you help a smallholder farmer? So we try and do it in 2 ways. One is to increase the efficiency of experts, the experts who have to go there to his land and advise him and create better breeds of the crops he wants to grow, and also want to enhance the capacity of the actual farmer. Right? So we want to empower him so that he can make certain local decisions on his garden. And so we try and tackle the problem from these 2 sort of levels. So when we initially began, so this is with the National Agriculture Research Organization, so the organization in Uganda responsible for agriculture research and surveillance and this kind of thing. And this is exactly what they do. So this gentleman with the clipboard is basically doing surveillance. So they go to the field, with paper form and sort of look at the plants and they score them. And so he writes on the paper, this garden, etc., he has seen how many plants and he has scored them for disease. And so the problem with this method, and this was about 4 or 5 years ago, is that it sort of has a 6 months turnaround because they have to get all these papers, they have to enter them and do double entry, and then someone has to, plot all this data on a map. And this takes a while to come out before they can look at the map and come up with interventions, right? And say, okay, in this area we have to develop better breeds and this kind of thing. And so one of the quick things we did was automate this, right? So this is a simple solution. So one of the interesting thing about social problems is that they are not static. So the way we approach problems so the problem is there and we sort of ping it with so many solutions until we try and solve it. So unfortunately, in social problems, they tend to morph with time and with the technology that you introduce to them. So one of the problems was this. So we just say, okay, now we can give you mobile phones, or we can build these forms on a mobile phone. You can sort of put in the data and can immediately be mapped. I think that was our big drive. Now you can map it immediately. You can see what's happening in real time. But what it gave us was a new data source, so images. So the ability to take images, if you can automatically collect data, then you can actually take the images just as well. And images then give you the ability to do other things. So like surveillance, right? So one of the things that followed on from this was the problem that they do surveys. You've made them electronic, but they rarely do them because they need resources from the government to go out and sort of drive all through the country and sort of take this data. And one quick way was say, okay, now we can try and solve that problem as well, since we are collecting them electronically. So maybe you don't need experts. Maybe we can crowdsource this data. So get the farmers to send in images of their gardens. So this was sort of the idea. And in this way, then you have some all year round collection of data, and you can sort of see the surveillance. You can do surveillance on the fly almost. And so we sort of, this is a map of Uganda, and we got a few farmers and equipped them with phones and had them take images. And so we tried this with 30 farmers initially, then we got 200 farmers. I said, okay, their phone, they have different types of phones, so we bought a cheap phone and gave it to them and said, okay, well, what can they do if they have the phone and they have the means of taking this image? And so they take images maybe every once in a while, every week or every 2 weeks, and send them up. And you can build a surveillance map. So the next problem that came was how do you incentivize them now that they are sending images? How do you incentivize them to keep sending these images? So initially we thought, okay, we're going to give them a phone. It's a new phone that's going to, have them sending images. And so the incentive of a new phone sort of lasted a couple of weeks. After that, they sort of got used to the phones and they were not sending anymore. And so we had to think again, how do we incentivize them? And then we came up with all these ideas using mechanism design, eventually to try and see which people we can incentivize. So some of them were recognition, just saying this week, these people have sort of sent in the most images. Eventually we came to micropayments. Can we pay per image? And in this way, can we control where they take the image from and the quality of the image? And then we had several problems that came from that, like people over-optimizing. And, if you take one image and, take several photographs of the image, then you get, a higher reward. And then we said, okay, now we're going to use the geo information on the image to understand, to pay you more. And then they jumped on a motorbike and then they rode around and took more images. So it's, eventually they blew the top of our budget, and then we're like, okay, now we need to control this. But so the problems kept morphing. But also with images, you also get this extra advantage that you can actually do diagnosis. So we also did diagnosis, given a bunch of images, can you extract features, and can you sort of score them for disease? And this problem sort of is, for example, this is cassava, and cassava has sort of the top line is sort of 5 diseases that you want to classify, but also for the experts in the Ministry of Agriculture, they also want to understand severity. So for each disease, they want to understand how severe is the disease. So the problem sort of gets compounded. But any initial things, extract features, put them on the phone, and score them. And then, you sort of get different flavors of the problem, right? So if you go to train this thing, so you go with a bunch of students, you take very well calibrated images in the field, they're center stage, nicely done with the phone, and, fairly lit. But if you have a farmer doing this in his field, he's not going to stand there and sort of look for the best lighting, and right? So he's going to take it, a little bit haphazardly. So you want to figure out how to automatically control this. So maybe you want to segment out the leaf, or you want to sort of score a measure of quality of the leaf that it takes, and this kind of thing. And then, we sort of move this to other diseases, and this kind of thing. So I'm also trying to highlight the people who did this work, because there were students who are also here. So in case you meet them, you can ask them hard questions. And then, so the problem morphed again. So we're scoring disease from visibly diseased plants, but then, the question comes, okay, what do you do with that? How do you mitigate this? And so you want to say, okay, now, can we score a disease before the plants become symptomatic? In which case you have some bunch of time in which you can actually apply an intervention. And so we started looking at spectrometry. And some of the early sort of experiments we did was, given a leaf that is visibly sick, can you sort of look at the disease parts and the healthy parts, and can you sort of predict based on spectra extracted from these leaves? And so this is it's a good problem, but the problem is that a leaf spectrometer is $10,000. So, now this is an extra problem. And so we figured, okay, maybe we'll print one. We'll just 3D print a spectrometer. And so we started doing some work in building this cheap sort of mobile phone add-on with, very limited tech that you can sort of put on a leaf and try and score for disease. And so the problem also morphed again. So the more we tried to do disease, then the experts came and said, okay, now we need you to control pests and symptoms. So the anecdote here is really that when we took this diagnosis up to the experts and said, hey guys, this is very exciting, we've sort of used images and now we can sort of do this thing on the phone, they said, this is exciting, but this is not, it's not too helpful for us, because we can sort of look at the plants and we can score them. What we really want you guys to do is to help us count these little flies, because they had to do this task and it's a very maddening task, because these flies could be in the order of hundreds on a leaf, and they have to count 5 leaves, and that's just one plant, and then you have to count 30 plants, and there are other sort of dynamics, like they have to count only in the morning, before the sun comes out, the leaves, the pests hide under the leaf, so they have to turn the leaf over, and then they fly, and all these dynamics. And so we can you build some sort of tool that can do this? And so we build this thing on a phone, take an image, and sort of just count these blobs of white flies. And, several. So one interesting thing here maybe that I should mention with these types of interventions for social good. So this particular problem of counting flies was, we thought we were doing a good job. So so if you look at this thing, there's a lot of error. So you miss some of the flies. So this is a hard problem because of the resolution of the image. Right, so if you want to get the whole leaf, then you have to position the phone high enough. And because of that, then you get limited resolution that you can identify all these whiteflies. Anyhow, so the problem with this is that once you showed it to them, they were like, okay, this looks good, but you're missing out some whiteflies. You're missing out this one, you're missing out the thing that's flying. Some of them are 2, but you've categorized them as 1. And so even if it's more accurate than a human being, the fact that they look at it and you've done it automatically, their sort of appetite for accuracy goes up, and they're like, no, this is not working. It's missing out some things. And trying to make it work very well is a very hard problem. And so one of the things we eventually came up with was some semi-automated thing. And I think this is something we've seen in most of the applications we've tried to develop or to deploy, that you eventually get to a level where you have to automate, do some semi-automation that a human being has to come in. And so we build this app that says, okay, if this is the score automatically, can you go in and intervene and sort of annotate them or de-annotate the things you're sort of looking at? Okay, I've seen the 5. High 5. All right, so that was it. So then several symptoms. The experts also wanted to understand extent of rot on a cross-section of a root. And so we also, these are expert tasks that they ordinarily, so the way they do this right now is that they just look at the roots and they score them visually. So they sort of look at it and say, okay, I think this is 30%, and that's it. So even providing them some sort of standard way of doing this is very helpful. So other things in agriculture are sort of markets, which have gone. Oh. Is that me? Oh. No, I think my laptop rebooted.
Oh, is it updating?
Hope not. No, I think it's just, I don't know, it's rebooted. Okay, let's see. Sorry. Man. Okay.
And how much time does he have left? Like questions?
Okay.
Okay. Can we jump straight to questions?
Okay, it's back on. Do you want, Let me just wrap up. Let me wrap up in the 2 minutes remaining. All right. So the okay. Okay, there are several types of examples, but I'm just going to go down to the last, maybe last slide. I had on some general thoughts of things we've sort of seen. So data sets is a big thing for sort of AI for social good, and we've seen. So using different types of data like telecom data which is cheap, like telecom data. People ordinarily collect telecom data, CDRs, the way they call and when they move and they update to the towers. So you have this cheap data that you can use to track movement. So there's a big element of ethics here. But if it's aggregate enough, you can track movement and detect things like disease or inequality because of where people move, or transport networks and this kind of thing. And things like images are extremely good as well. And images are so in a place like in Uganda where you have 100 languages or more or less, then images become a very easy means of data for people to consume and to collect. And the problem there again is sort of how do you send feedback, which is sort of the second thing. How do you give feedback to people who have 50 languages, so you can't send text. So you want to figure out a way of sending maybe an image. And sort of the people in advertising have sort of gone a long way there. But how do you do this such that you can send a message using an image that's sort of universal? And then problem specification. So we've had a big, I think one of the biggest problems here is really specifying a good problem in a way that you can automate it. And then there are very many social contexts to problems. And then the context, of course. So I'll stop here and take any questions.
About the way to incentivize farmers, I wonder if you've thought about paying them in proportion to how much their examples are improving the generalization error on the test set. Because that's the ultimate thing you're trying to get at, right? So if they cheat in any way, it's not going to help much the generalization. And if they duplicate examples, for example, it's not going to help generalization. If they collect very diverse sets of examples, it will help generalization. So you want to make their incentives as much aligned as possible with your incentives.
All right. So that tends to be a hard problem. So one of the things we try and control for is the social problem. So you want to keep them engaged. So you want to make sure that they are. So imagine a farmer sends an image. So he has spent some amount of money to send this image, and it's a wrong image, for example. It doesn't improve your algorithm any better because, So what do you do with this kind of thing?
You don't want to do it on a per image basis, but let's say every week or every month, they get a payment which is proportional to how much all of the images they've sent in that period are helping in a leave one out kind of manner the generalization in the existing data sets.
Yeah, I mean, that's definitely one of the things we're sort of looking at.
It's not too hard to instrument.
It's not too hard, but the other things that sort of come with it, things that are, I mean, what happens if the image is poor? Do you pay him less?
Yeah.
Okay, and then...
Poor in a machine learning sense, in the sense, for example, if the lighting is so bad that you can't get any information out of it, so they will get an incentive for doing a better job.
Yeah, so we actually thought about this, and one of the things was to actually put it on his side so he doesn't have to send the message. And this is one of the things. Can you build that intelligence on the device itself so that as soon as it takes, it says, no, this is not a good thing. So
You could.
Yeah, that would sort of solve both problems, yeah. Yeah, that's a good suggestion. So, thanks. Yeah, so one of the things that all these data sets should... Oh, the question, yeah, she was asking whether the data sets we've collected are publicly available. So we're making them all publicly available. I think there's one, I think the disease data is going to be used for a competition, hopefully if that proposal goes through. And all this data is supposed to be made publicly available. This is what we sign on when we collect this data. Yeah. A lot of it is actually, if you go to our site. Okay, thank you.